Hi, my name is Brian, and today we are going to use limits in a table of values in order to find the slope of a tangent line on a function. So officially, the question is, find the slope of the tangent line on the function 1 over x at x equals 1/2. So we're going to go ahead and graph this so we can get an idea of what we're talking about, and then we'll set it up as a limit. So we have 1 over x, let's look like this, and let's just say 1/2 is right here. So we have the point 1/2 comma 2. Now the slope of the tangent line, or just the tangent line, is right here. Okay. So I want the slope of this line. So what we're going to do is we're going to find secant lines and find the slope of those secant lines, and then set up a table of values in order to find the slope of the tangent line. So a secant line is just a line connecting 2 points on a graph. So we could take that point that's fixed because that's where we want our tangent line to be, and we could take another point over here, and then when we connect the two, this is going to have a slope. And we're going to start, so let's say this was at 1. And so we have a slope of this line. And then I'm going to start choosing values closer and closer to 1/2. So we can choose, say, 0.75. And that would give me the point here. And we would connect, which is going to be very tricky to do right now, but we're going to have, I don't know if you can tell the difference, but there's a slope on this line. And you can see that this line here, as the point moved closer, my new secant line got closer to the tangent line. And then as this point gets closer and closer, those secant lines will eventually match my tangent line. Now to find the slope of a secant line is just it's how you find the slope connecting 2 points. Okay. Now these are any 2 points, x1, y1, and x2, y2. We specifically will always have 1/2 comma 2. So that we're going to right here. So it'll be y2 minus, again, 2, because that's always y2, and then x2 minus 1/2, because that's always going to be the x value, or x1. Okay, so I don't really like the x2, y2, because this is going to be, the x2, y2 is always going to be the point moving on this line here. And since that's going to change, I'm actually just going to call that x. And then instead of y2, and really instead of y, we can call that f of x. So that's a formula that will generate all the slopes of the secant lines. And we're just going to keep letting x get close to 1/2, and we'll see what happens. Now this function, let me write it down, can't quite see that, it's a little too high. Yeah, we'll do that. Is 1 over x. So now what we're going to evaluate is 1 over x minus 2x minus 1/2. So this is the function, so let's set up our limit. Okay, the slope of the tangent line. I'm going to have the limit as x approaches 1/2. And all my secant line slopes are going to be 1 over x minus 2 over x minus 1/2. In a previous video, we went over how you construct a table of values in order to find a limit. It's going to be the same here. We're going to set up 2 different tables because this is a general limit. That means x can approach 1/2 from both the left-hand side and the right-hand side. Let's go ahead and start with the left-hand values. We have x, and then we have that function. All right, we'll kind of squeeze that in here. That's going to be the 1 over x minus 2, x minus 1/2. Okay. So I wrote down the table of values before we started the video, just so I can get an idea of what it's going to look like. Again, I'm going to put the calculator up here showing you how I evaluated all these. So now since x is getting close to 1/2, I think from the left-hand side, let's start with 0.4. Now again, because 1/2 is 0.5, we'll start with 0.4, and then we'll go up to 0.49 and 499, and yeah, let's go 499 and 9. So I'm going to plug that into here. So again, on the calculator up top, you're going to see I plugged in 0.4 and I get -5. Okay, keep going. So 0.49 is going to be -4.08163. So 0.49999, sorry, is 4.00802. And 49999, so 4.0008. So it does look like as we're getting close to 0.5, these values, which represent the slopes of the secant lines, getting really close to -4. So right now I would expect if the slope exists, it's going to be -4. Let's confirm this by doing the right-hand limit. So x will approach 1/2 from the right-hand side. And if we also get -4, then we can conclude the slope of this line is -4. All right, so that's going to be 1 over x minus 2 divided by x minus 1/2. Okay, since we're coming from the right of 0.5, we'll do 0.55 and 0.51, 501, 0.5001. I think that will be good. All right, so if I plug in 0.55, again, take a look at the calculator, I get -3.63636. Then 0.51, I'm going to get -3.92157. 0.501, -3.992. I believe it's 0.2. Again, the calculator will confirm that. And then finally, 0.5001, we get -3.9992. So as we're getting close to 0.5, these values getting close to -4. So then I think we can say that the slope of the tangent line slope is -4. All right, anyways, thanks for watching. Bye.